Let's talk about SUSE Virtualization disaster recovery with CloudCasa, including a demo. My name is Alejandro Bonilla. I'm a domain solution architect for SUSE. Here's an introduction to SUSE Virtualization. If you're already aware of it, just skip about 2 minutes in this video and we can then talk about disaster recovery. For those that don't know SUSE Virtualization, it is a turnkey solution that reduces the reliance on costly SAN HCI hardware, built on 100% open source components, and its purpose is to bridge the gap between legacy virtual machines and cloud-native applications. Has a very familiar interface for virtual machine administrators. Then it allows us to manage containers and virtual machine workloads side by side. It will also allow us to manage cluster level components, compute, storage, and networking in one place. From the bottom up, the open source components that make up SUSE Virtualization are SUSE Linux Micro, which is our lightweight and mutable version of SUSE Linux. Then Rancher Kubernetes Engine 2, which is what we use for the Kubernetes platform. SUSE Storage, that is our software-defined cloud-native storage. KubeVirt, which is the tool that allows Kubernetes and KVM to talk to each other. And Multus, it's our meta CNI that allows us to plug in different networking capabilities. Which are some of the use cases for SUSE Virtualization? Number one, we can run containers on the metal itself. So yes, the host itself can run containers. Why? For low latency workloads, higher throughput workloads, or any of those workloads that you would expect behave as a bare metal workload, right? Where you want bare metal performance. Second use case is hosting virtual machines. That is the classic hypervisor use case, running your Windows, your Linux VMs, as you would have before, for example, on KVM. And then a very specific use case, which is with Rancher included, that is provisioning Rancher Kubernetes clusters on top of SUSE Virtualization so that you can have isolation of workloads, so you can provision Kubernetes clusters with a specific CNI, Kubernetes version, pretty much manage the entire lifecycle of that Kubernetes cluster. And of course, you can do all of these at the same time. Why would we do that? Why do we want to run containers and virtual machines on the same platform? So that we can assess, as we do a migration from other environments, which of those virtual machines should be a container. Should that application server or web server really be a bulky, large virtual machine with a footprint of an operating system, agents, and packages that may not really be necessary? Can we deploy that as a container? And even if we're not ready to do some of those transitions, we can have a platform that will allow our team to eventually do so. This is the architecture and more of a cluster view architecture of SUSE Virtualization. First of all, we have a clear definition of our network, then the components of our servers. That includes the connectivity to external storage, onboard storage on the server, so that we can create different tiers of that storage with SUSE storage. And then the additional components that sit on top of it. That is the Kubernetes, or the orchestrator, KubeVirt, and everything else that is needed to manage our virtual machines. All right, that was SUSE Virtualization. Let's talk about data protection and disaster recovery. First thing is, because SUSE Virtualization, when used on HCI mode, has SUSE storage. SUSE storage provides its own replication system of the volumes, and of course that is our virtual machines. That is, if a host fails, we have another replica for that virtual machine to start on another host based on affinity, anti-affinity, and placement rules. We also have the capability of kind of as a stretch cluster, right? So we can have a 3-site configuration, of course, being very latency sensitive, in which a witness node will identify should one of the sites go down, we can really determine which is the site that is still active. That allows us to then move workloads and assess where the workloads should be so that they're highly available. Another option is a cross-site disaster recovery using a storage array replication. That is a external storage, making sure that our virtual machines are synchronized across sites, and the data replication is as we've configured it with our RTO and RPO expectations. And another option, which is what we'll talk about today, is using CloudCasa for cross-site disaster recovery. Pretty much how this works is we utilize an agent on each cluster, and then that agent performs a backup on a third-party storage, that is AWS, Azure, or an S3 compatible storage, and then hydrates a disaster recovery cluster with the virtual machine and volumes and the spec of all the components that we have in our primary cluster. Let's jump into a demo and let's see how that looks like with SUSE Virtualization. Dashboard. Today we will be working with 2 clusters, retail store and disaster recovery. We will be replicating virtual machines across these clusters using CloudCasa from Catalogic. To install the CloudCasa extension, first we click on the Rancher Prime extension section, and then we install the extension. At this point, it's already installed, but all you have to do is click on the CloudCasa section and configure the extension by providing an API key, prefix, and the CloudCasa API endpoint. Once that is in place, we will see the list of available clusters from Rancher. I've already clicked the install button on our retail store and disaster recovery clusters. That installs the CloudCasa agent and allows for the software to operate all the operations that are required and scheduled. Let's go back to the main dashboard for Rancher Prime. And then if we click on the Harvester link, we will see the main dashboard for SUSE Virtualization. We're going to focus on the fact that we have a virtual machine called Save Me in a namespace called Replicated. If we go into our other cluster, that is the disaster recovery cluster, we'll click on the Harvester link. And if we go into virtual machines, there is no Save Me virtual machine. And if we go into projects namespaces, there is no replicated namespace. So let's go ahead and replicate our replicated namespace from one cluster to the other. We do that by going into the CloudCasa extension and clicking the CloudCasa dashboard. At that point, we'll have access to our dashboard, and we can go into clusters, replication. Then we will define a replication utilizing our retail store cluster, and then selecting the replicated namespace. There are additional advanced options, but we don't need to choose any of them at this point. Next, we're going to choose our target cluster where we're replicating our namespace. We will use the disaster recovery cluster. And we don't want to rename the namespace that we are replicating. We do want to change the storage class. Although I could have extracted away this in this demo, I really don't want to because I want to just provide an example change. In our retail store cluster, we have a namespace, a storage class called ToReplicas. we're going to change that to Harvester Longhorn, which is where I would like our disaster recovery namespace to be set up. All right, so again, this is just how you would map one storage provider from one cluster to a different storage provider to the target cluster. Okay, and again, we won't rename namespace. We do want to replicate to a different storage backend. And there are additional options. For example, this VM option where it would clear the MAC address. That is a good idea if you don't have the same network on your target cluster, but in this case, I do. Therefore, I want to preserve the MAC address so that the IP address on the VM also remains the same. Additionally, I want my virtual machines, once replicated, to remain halted. I do not want these VMs to be started after the replication because they're only there standing by should there be an issue. I will go ahead and click next. Now we could configure hooks for any type of operation that we might be doing. Let's say that there are some databases and we want to do crash consistent replication, so we can add these hooks into the section as well. We're not going to do that in this demo, but that option is available. We're going to go ahead and click next. I had already created a policy that runs this specific replication daily. It's pretty much a schedule. It will run daily at 1 a.m. But of course, you can create a policy in which this replication happens, for example, every 30 minutes. We'll go ahead and click create next and set the replication name to replicate DR replicated namespace. We can run it now, and we can also set our retention period. I'm going to set that to 5. All right, so we'll go ahead and click save and run. Perfect. So at this point, we have created our replicate DR replicated namespace replication, which is going to copy the replicated namespace from the retail store cluster into the disaster recovery cluster with a policy that is going to run daily. Additionally, this job is going to run now because we've selected to do that. And if we click here in the section that says in progress, you can see this is already running. As we click on it, we can see the activity log. We can see any persistent volumes that are being copied over and any additional details of how other items are being copied from the source to a intermediary storage and then restored from that storage to our disaster recovery cluster. We also have a list of virtual machines. The VM spec of that VM has already been copied, but the disk isn't there yet. So we will wait a little longer for the entire replication job to execute, and we'll come back to it. For this, we're going to give it about 5-10 minutes and come back to the video. A few minutes, so we can now continue looking at the activity log and what's happened. We can see that the CSI snapshot for the persistent volume of the Save Me disk has taken place. It has been fully copied over, and the restore has also taken place. We already knew that our virtual machine spec was also copied. If we look into the activity log, we can see further information, including the fact that we did not have a namespace in the target cluster and how we're restoring our resources and how that is complete. I'm going to go ahead and click OK and see that there are no longer a job in progress and switch back into Rancher Prime. At that point, if we remember that we have a virtual machine in a retail store cluster that was called Save Me, that's its IP address, and in a replicated namespace. Now we can look into our target cluster, which is called Disaster Recovery. We can now see that we have a virtual machine called Save Me on the namespace replicated. As we can see as well, that virtual machine is off. Now, what we can do from there on is create a script that allows us to switch from one side to the other based on a failure. Now, Rancher Prime provides the ability to understand how to construct our own API script. Now, these are some of the operations that are permitted immediately in this VM because it's off. Therefore, you can start it. So how would that look like? So we can pretty much click here in the right side menu in the operations list, click Start, and then Show Request. And it's showing us how that curl command would be executed to then start that virtual machine so that we can create our own script. So let's go ahead and do that so that we can stop the virtual machine in the retail store cluster and switch it over to our disaster recovery cluster. To do that, let's switch over to a script I've already created. Let me show this script. And we can see that at the beginning, what we're going to do is stop the Save Me virtual machine in our retail store cluster, and then verify that the status of that virtual machine has changed while we retrieve the VM status. Once its status is changed to stopped, then we would go ahead and start the virtual machine on our DR cluster. Okay, so let's go ahead and do that. Right, so as we wait for the virtual machine to stop, then now we know the script has confirmed the VM has stopped. Then we send a request to start our other VM. Let's go ahead and switch over to the dashboard and have a look at that. There we go. That virtual machine has now started in our disaster recovery cluster. Once it comes up, we should see its IP address as 10.0.0.38. It just needs to happen once the VM has started. And it has. Perfect. So we went through the installation of the CloudCasa extension, the configuration of that CloudCasa extension, installing the agent on both clusters, then defining a replication of a namespace that included a virtual machine called Save Me, then executing a job in which the replication takes place across both clusters, and utilizing the Rancher API, creating a script that stops the virtual machine on their primary or retail store side, verifying that it is indeed stopped, and then starting the virtual machine on our secondary side called disaster recovery. I hope this video has been useful, and stay tuned for the next one.